GATE 2012 Civil Engineering Question 10. The ratio of the theoretical critical buckling load for a column with fixed ends to that of another column with the same dimensions and material but with pinned ends is equal to. The four options given are A 0.5, B 1, C 2 and D 4. The relevant NPTEL reference has been listed. So coming to the useful data, when we talk about Euler's buckling load, it gives the critical load of a column, which is pi square EI by the effective length whole square. Here E is the modulus of elasticity of the column material, I is the moment of inertia of the cross section of the column, and LE is the effective length of the column depending upon its end conditions. So namely, four standard conditions exist. The first one is when both ends are pinned. For this case, the effective length is equal to L, that is the length of the column. When both ends are fixed, the effective length is half of L. When one end has been fixed and another is pinned, the effective length is 0.707 L, which is another form of L by root 2. And when one end is fixed and another end has been left free, the effective length turns out to be 2L. So depending upon the end conditions, one needs to choose the effective length and substitute it back in the formula to obtain the critical load. So in this case, we have been given two columns which have the same material. So E1 is equal to E2 is equal to E. It is also given that the cross section is same. So I1 would be equal to I2 will be equal to I. So let us assume PCR for the column with fixed ends will be equal to pi square E1 I1 by LE1 whole square. So this would become pi square EI by effective length square. So for a fixed column, the effective length is L by 2. So substituting the value, we would get L square by 4. So this would become 4 pi square EI over L square. Now we will do this for the column with the pinned ends. So that would be pi square E2 I2 by LE2 whole square. So since the material and the cross section is same, the numerator would remain the same and the denominator would be L square. Let us say this is equation 1 and this is equation 2. It is said to find the ratio of the critical load for the fixed end column to the critical load of the pinned end column. So by dividing equation 1 by equation 2, we would get the value as 4 pi square EI over L square divided by pi square EI by L square, which would turn out to be 4. So the ratio of the theoretical critical buckling load for a column with fixed ends to that of another column with pinned ends is equal to 4, that is option D. The relevant NPTEL reference has been listed.